All right, so since we're basically done with the entire curriculum, we are going to do the workbook a bit. Anyways, let's start with lesson two since we already completed the first one before. So, can anybody try to explain to me why different liquids boil at different temperatures? Anyone?
It did this.
Anyone? Would anybody like to explain why this phenomenon happens?
Because it's made of different things and different elements.
Yep, they're made of different elements. Now, how does this prove our theorem true? Why does being made of different elements lead to this fact?
But some elements boil faster and some elements like boil slower and does not conduct many heat.
So yeah, that is a decent explanation. Different elements have different boiling points. So if they combine together, your boiling point will basically be an average of those two, or a percentage. Now, this graph shows the temperatures at which some liquids boil. Can anybody tell me which liquid boils at the highest temperature?
Oil.
All right, yes. And which liquid boils at the lowest temperature?
Nail polish remover.
Yep, that is true. Using the graph, it is a bit obvious. Now, can anybody tell me at what temperature does car engine antifreeze boil?
135 degrees Celsius.
All right. So, yes, it is approximately 125 degrees Celsius because, as you can see here, the as you can see in the wait, as you can see here, the car engine antifreeze looks like it's in the middle of 150 and 100. And we know that at the middle of that is 125. All right. So, name another process in which the same change of state takes place.
Oh, cảm ơn.
All right. So, can anybody tell me another word for boiling? A different word for boiling, basically. Anyone?
Can you ask a question again?
Can anybody tell me another process in which the same change of state takes place? So another word for boiling, basically.
Boiling water. I didn't know that. Can you explain?
So is so there is another scientific term for boiling, which is what?
Is can.
It's not exactly the answer I was looking for. Can anybody try to tell me?
Eating,
What?
eating.
Mm, what? That's the thing that's required for things to boil, but I want another word for it. It starts with an E. Anyone?
Every
All right, so the word I was looking for is evaporation. All right, it's the same change of state because it goes from liquid to gas, which is what boiling is. Have you ever tried boiling water, guys?
yeah.
Yes.
Yes.
Yeah, and that
My school
process,
even when my school have a ringing golden contest, my school even takes ask a question that what's the temperatures of a boiling water? I just only four student answers correct. That's me and three other friends.
that's nice to hear. At least you know something. It is, I mean, it's something obvious though, but props to you and your friends. Anyways, yes, vaporization is also technically a correct answer. Evaporation is also a correct answer, but you should remember both words too. So, anyways, um, so can anybody mark me the boiling point of acetone?
Don't remember, but I just remember the water boiling. The water is 100 degrees.
Yes, but we have the numbers here. You need to mark it on the on this thermometer with the annotation tool.
Okay, so is this is boiling water.
No, we
This
start with the boiling point of acetone first. The acetone first. All right.
is about
So,
is here. I see it.
all right. So the thing here is, you guys are this is 55 degrees Celsius, but what they're asking is 50.5. So what should be a bit the answer is around here, right? Because it's 50.5 and not 50. Okay, so you guys are nearly correct. You guys are correct with the range, but you should put the number closer to 50 than to 60. All right. Can anybody graph me the melting point of candle wax in candle wax using annotation?
Yeah, 60 degrees.
Yep. Uh yeah, around that range. 60 degrees. All right. Now, can anybody graph me the boiling point of water as an annotation feat on the annotation?
Me. There is water.
Yep, that is water. As you can clearly see, the 100 degrees Celsius is up there, and the boiling point of water is 100 degrees Celsius. So yeah. Anyways, can anybody tell me which drawing here shows boiling? All right.
B.
Why is it B? What's the difference?
Because one the because B have more B have more has higher temperature than A.
The bee has bubble and the I have
Yeah, we have air bubbles and A doesn't.
All right. So yes, B is boiling because it is at a way higher temperature. Yes, and
Look at
also
this.
it's and
Also look
it's
at this. It's this one.
yes, the thermometer is higher. Yes, I know, but let's not. Yes, that's also true. But the main reason here is that the water is at a higher temperature, so it's actively trying to be evaporated. However, in this situation, you're only evaporating because the temperature is lower.
No, but it's
Now, all right. The thing is, the boiling point ensures that all water all liquid will turn into gas. However, that doesn't mean that things can't boil, things can't evaporate below that temperature. So if I had a cup of water that's 50 degrees Celsius, you will still see some water vapor, which is why when you go into the shower, you can see a bit of vapor. So, knowing that, can anybody tell me what the other drawings show? Anyone? Oh, sorry, here.
It shows that even not boiled water can evaporate.
Yeah, the other process shows evaporation because it isn't fully there. It's only an half active process compared to boiling, which is an active process. Now, can anybody tell me what is the one thing that could be the same about both processes? Anyone?
Water evaporate.
Um, both do how do I say it? Both do lead out water vapor. Yes, that is true. Now, can anybody tell me two things that are different about these processes?
One is boiling and one is not. One is hot and one is cold.
Can anybody tell me the difference between these two processes? Anyone?
The A doesn't have the bubbles, which means evaporating. B does. A doesn't have a thing under it, like to boil the water. B does have it. Uh, A shows A shows arrows that are going up, and that's only a little bit. So, but B doesn't. A shows evaporating, and A thermometer uh, is at a lower height, and B has a higher height.
All right. So so the main difference between these two things is the temperature and how these evaporate. One evaporates quickly, while the other evaporates slowly and will not evaporate fully. So yeah. Anyways, can anybody predict the temperature in beaker A and beaker B? We're also gonna assume that beaker B is water, okay? So
B is 100.
what about A?
Um, about from about 25, about 20 or more or higher.
Yep. The actually A could be A could be a huge range. As long as it's under 100 degrees, it is technically correct. But yeah, you should assume that A is at room temperature because we're in a classroom. All right. So, all right. So, these are the boiling points of three liquids. Can everybody order the liquids from one with the highest boiling points to one with the lowest? Everybody try to order this. This is very easy and simple.
In water.
100, 100,
118,
water,
baking
300.
vinegar, olive oil. 100, 118,
Olive oil, vinegar, then water.
Water 100 degrees, vinegar 180 degrees, and lastly, olive oil 300 degrees Celsius.
All right. So yes, you start with olive oil as the highest boiling point, then vinegar, then water. This is simple enough. Now, if 100 milliliters of all three liquids are heated at the same Bunsen burner for the same amount of time, which one will turn to the gas first? Please do not heat any liquids yourself. So, anyways, which
Water.
one why do you think it's water?
Because water is the lowest height, but boiling point, so it will turn to a gas first, then the other.
Can I see the chart for it?
The 100, I think it's water because degrees Celsius of the water is the lowest, and the lowest means it boils faster, so it will evaporate faster as well.
So it don't need much temperature for it.
Well, all right. So water is going to be the first one simply because it has the lowest boiling point. Simple as that. You don't need to explain anymore.
This
Anyways.
is
Anyways. Now, draw a bar graph to compare the boiling points of water, vinegar, and olive oil. Can somebody try?
okay, but I need the chart. I need to see the chart one last time to do this.
Would anybody like to try this?
This is water. This is vinegar. And this is oil.
So the drawing is it's accurate, yes, but now we just made it inaccurate. Okay, so yeah, all right. So if that's 100, all right. You guys are a bit further away, but I'll take this answer. However, you do need to know that it's generally in a rising pattern. All right. Now, thermal and electrical conductors. Look at this picture of a lamp. Can anybody tell me which parts of the light bulb are electrical conductors?
The conductors are wires, support wires, and metal filament, and screw-in. The screw-in wires, support wires, and metal filament.
All right. So, all right. So, yes, these those parts are definitely the parts that require that are electrical conductors because they're mostly made of metal. Now, can anybody tell me why the plugs are made of plastic? Why is it not made of the other?
That because if you using a glass bulb, you using a metal glass bulb, it may contract with electricity, making up its shock.
That does not.
So the plug needs to be plastic because it is a insulator and don't have a Shock.
Yes, it is not conducted with electricity. If we conduct it like that, you may get shock.
It will protect you from the electricity that will shock you, and it will separate the wires.
Yes.
And in short, it does not conduct electricity because glass does not.
Yep. So yeah, if you use a electrical plug that's not made of plastic, or is rather some stuff like metal, you might get shocked and you might possibly die.
And it's a bit heavy, so when you bring it anywhere you want, somewhere it will be too heavy. And by the way, it can't bend like rubber or plastic.
Uh-huh. All right. So, hmm. All right, let's continue. So, why would your hand get burnt if you stirred hot soup with a metal spoon?
Because the temperature of the hot soup will get
heat.
the hot soup's
How
temperature will be passed
hit it.
into the metal spoon and into your hand. It will get burned.
So, yeah, that is true. You will probably get burnt if you did stuff like that. So, I would suggest you don't stir hot soup with a metal spoon and use something more like a wooden spoon. All right. Anyways, as you can see, I've already told you that you should use a wooden spoon and not the other type of spoon. So yeah. All right. Anyways, now this table shows how common metals conduct heat. A high value means that it conducts heat very well. Now, somebody explain to me. List the metals in order from best to worst conductor. Anybody? Can we list the metals from best to worst?
Next is silver, next is copper, then aluminum, brass, and iron, then finally stainless steel.
Copper, silver, copper, aluminum, brass, iron, and stainless steel.
So silver, copper, then aluminum, brass, iron, and stainless steel.
All right. So, you start. Yes, you start with silver. Then you go to copper. Then you go to aluminum. Then brass and iron. Then stainless steel. Anyways, so can anybody tell me why do some cooking pots have a copper bottom? Why do some cooking pots have a copper bottom? Why not something else? Why copper?
Copper conduct heat faster and better.
Anyone can
Is it B,
explain
C?
what?
Are you asking B, C, or D?
I'm asking B. Why do some cooking pots have a copper bottom?
Because copper is a great conductor and a heat conductor. It is a good electricity conductor and a heat conductor. So the heat will pass through easily, and it will boil the water, and it is less expensive than silver.
So yes, it is Yes, copper is used to transfer heat very well. And the reason why they are not made from silver, even though silver is better, is because silver is a very expensive material. And it's only better by a little bit. It's not too good. So you aren't really profiting anything when you're doing that. So yeah. Now, why car radiators which cool the machine are made from copper and brass? Anybody? Why are they made from copper and brass?
I don't know. Can you explain it?
Well, I can't really explain it. You guys have to try to figure it out.
It's
So what
a
a copper
conductor
mean?
and
What do
it
coppers
has the
mean?
heat inside and it does not
Hey, what is
out.
copper means? What is copper means?
Copper is didn't I already say copper? Copper is this metal. So why are these car radiators that cool the engine made from copper and brass?
Because actually it made of a cool.
But it traps the heat inside and does not let the heat out, so it cools the engine.
Because of cool materials that do not contract with heat. It do not contract with heat.
Yes, copper is a good conductor of heat, so it keeps heat in, and it make cools things down because it conducts heat well, so it takes heat into itself.
It conduct with heat very high. It comes to 400.
So, anyways, will a block of ice melt quicker in a plastic dish or a metal dish, and why?
Metal dish, because if it is placed in a hot room, the metal dish will conduct heat better and melt the ice faster.
Anyways, um, anyways, so a block of ice would melt way quicker in a metal dish of the same size because the metal dish conducts faster.
Hiểu anh nói gì không? Em ngồi đi nghịch chat.
Anybody explain why this happens? Anyone?
Is no metal dish actually
The
that because it
metal
was
dish
a conductive
will trap heat better.
material.
Đấy.
That because it's a conductive material.
Are you asking the A part of the question 3?
Mhm. All right. So, all right.
Because matter is a
All
thermal
right.
conductor.
So a block. So if you touch a metal dish that contains an ice cube and a plastic dish that contains an ice cube, which dish would feel warmer and why?
The plastic dish.
Okay.
Plastic dish.
Yes, it is the plastic dish that contained an ice cube that would be warmer because it conducts heat way better. So it would be way so the no the metal dish would be way colder because you emit too much because you because it's already had too much conducting into the ice. So basically, the amount of this will be way colder, simply. Now, Class 6 asked the question, is graphite an electrical conductor or not? They carried out an investigation to find out. Each group tested different lengths of graphite in a circuit and measured the brightness of a lamp in a circuit of scale from 0 to 5. Averages of the results are shown in the table. Now, can anybody tell me the dependent variable? Dependent variable. Anyone? Anyone? Anybody like to explain to me? All right. Can anybody try to explain to me what the dependent variable is? Anyone? The dependent variable is what you're trying to look for, or what I could say is the variable that is dependent on the independent variable. So, um, what is a dependent variable? Anyone? Anyone? Would anyone like to explain? All right. So, in this question, they asked us for the dependent variable. And the dependent variable is the one that you're looking for. And since you see that the average brightness is changed by the independent variable here, the dependent variable has to be the average brightness. Similarly, the independent variable here is the length of the graphite because you can change that, right? Think about this. Dependent variables are the ones that you can change. You can't change. Sorry, you can't. How independent variables are the ones that you can change in an experiment. The control variables you can't change, but you need to keep it the same so that the answers can be the same. All right. So, guys, is melting butter on a hot pan reversible or irreversible? Anyone?
Not reversible.
What?
Not reversible. Irreversible.
Well, can you turn that butter back in does the butter change?
Yes, it does.
So is it irreversible?
Wait, can butter be made back into butter?
Can you freeze melted butter?
It can be reversible.
All right. So yes, you can freeze butter. All right, we can freeze butter. you could theoretically freeze butter. So, anyways, now, is baking a cake reversible or irreversible? Anyone? Anyone?
I think
Can you?
irreversible.
Oh,
Why? Can anybody tell me why?
you can
Because it
change
can't turn
a cake
back
into
into
batter.
cake it can't turn back into what it
You can
is.
turn a cake into batter or flour or egg again.
Yep.
Because you can't turn a cake back into its ingredients.
Yeah, you can't change the cake back into the ingredients. So of course, baking a cake would definitely be an irreversible change. Now, is dissolving salt into water reversible or irreversible?
Reversible.
Why?
Because when you evaporate the water, the
But
salt
if you
won't evaporate.
the salt will appear.
Well, yeah, you are correct. Um, dissolving salt in water is irreversible. Is reversible. Now, what about burning wood on a fire? Is that reversible or
It is
irreversible?
not. It is irreversible.
But we will turn into ash and cannot turn into fine wood again.
Mm-hmm. Yep, that is correct. Now, what about rusting on a tin can? Can you unrust it?
No.
Because if we rust it, there will be nothing of it.
Mm-hmm. All right. So now, this picture shows a test to find about factors that affect dissolving. What factor are we testing here? Anyone?
Salt,
Anyone?
salt, sugar.
Well, can somebody try, please?
Is that testing? Yeah.
All right. So the factor that's being tested here is the concentration. Now, can anybody tell me? Oh no, sorry. There are two factors. There's only one factor. Yeah, there is the concentration. You can also technically count the temperature. Yeah. Anyways, so which factors here are the same in both beakers? Anyone? Anyone? All right. Since no one is explaining, the factor that affects the solving that is being tested here is oh wait, no, sorry. The factors that are same in both beakers is first of all the water amount. Second of all is the type of beaker, and third of all is the type of dissolvent you're using and the number of dissolvent. Now, the only factor that's different here is well clearly the temperature. Uh, unfortunate. Now this is a fair test if this showed the results. Since if it doesn't show the results, it would be a bit unfair. All right. So yeah. Anyways, let's continue on. Now, I believe that we could be finished now. However, let's play a game of Look It to review today. Give me a second.
And we play.
Yay.
Play Game Kid.
Can we
Play
play
Game
Candy
Kid.
Kingdom?
Play Game Kid.
I can play Game Kid.
Game Kid. Game Kid.
Well,
I got Game
today
Kid.
we don't have
Game
game.
Kid. Game Kid.
We don't have game. Okay, wait.
Game
Sorry.
Kid. I have a Game Kid.
Game
Yeah,
Kid.
I have Game Kid too.
Who asked?
So yeah, see you everybody.